Hi, myself Ashit Varun, and my team is Aditya V, Kiran Akshay, and we are all boys from AD class. And my project is AI-based smart waste management system. In this, we try to segregate waste and make use of that waste in certain ways. And I would like to thank our guide, Ms. J. Bona, who helped us a lot through this creation of and publication of this project. So, our problem statement. In today's world, waste is not much that much segregated. We in India we almost see waste. Waste is a huge problem for India. It's not basically segregated, separated, or processed. We just throw our waste on roads and it stagnates. And the bins are not properly filled, and the, and even the waste in the bins are not completely processed. It just gets thrown to some wasteland, and the huge area will be not of use. It will just be in wasteland, and that further creates so much problems like land pollution and air pollution. So we decided to reduce this waste and recycle this waste to some extent using our segregation technology. So waste management is a critical challenge in urban environments, like I said. Our project is AI-driven smart waste management framework, which uses CNN for automated waste image classification and predictive analytics for forecasting waste generation trends. We do not just stop at just predicting the images and classifying it to further features I'm about to discuss. We will also predict those features, like let's just say waste will get more stagnated more in numbers in these particular days, like predicting upcoming disaster and then taking certain actions for preparing for the things. This system classifies waste into categories like just I said, organic, recyclable, non-recyclable, etc. This classified data is stored and analyzed using historical patterns and predict future generation using time series forecasting. We are going to use ARIMA in this auto-regressive integrated moving average for this time series forecasting models. Yeah, we focus mainly on efficiency and reducing operational costs to some extent. For our project, we referred already existing papers, but they didn't go to the extent of making this happen on a industrial scale. But we have a chance and an idea to make this happen using this industrial setup. So these are our literature reviews. These are the papers we all refer. What are the issues and challenges we are currently facing? Like manual waste segregation is not so efficient and it's error prone. Mostly some areas only it will focus on segregating this waste. So there's lack of automated waste classification, fixed collection schedules, and poor resource utilization. The problem with fixed collection schedules is not all time the waste will get stagnated at same rates. Sometimes it will be high, at some time there will be no waste. In cities like Chennai, not all people staying in Chennai are natives, right? So there are people, when it comes to festival season, they may have to leave Chennai and move to other cities to their natives. So that and at that time, Chennai cities will mostly be empty. So we can reduce the amount of service and collection works to some extent, so that timing and energy is saved. So no accurate forecasting of waste generation trends and overflowing bins, like, yeah, this is the problems of fixed scheduling. Our proposed work is as follows. We utilize CNN to automatically classify waste images into organic, recyclable, and non-recyclable categories. It stores and analyzes classified data to identify historical waste generation patterns. With yeah, as I said before, we, we calculate this waste generation pattern on how many days, how much amount of waste is generated and classified, on whether in these days this much amount of waste will be generated or it will not be generated. We can just save time and energy. Like I said, applies time series forecasting models to predict future trends for different zones. We implement an AI-based smart scheduling model to optimize collection frequency and resource allocation. Unlike traditional system that operates on fixed schedules, which cannot be tolerated to some extent, and it almost utilizes more amount of time and energy, which in today's world cannot afford it. We just need the energy to somewhere else. So this is our architecture diagram. So let's say um, I said we placed camera on top of a bin. From that bin, it lively captures the images of waste and it classifies on on live. So it classifies based on CNN model and it gets stored in a central database. And using those database, we can almost predict, predict using ARIMA time series forecasting, and we can generate reports and visualization on what areas, at what amount of time, how much amount of bins getting filled, and at what times and what period of times it's getting filled often. So we can allocate staff members or collecting bins or vehicles for collecting to that particular area a little amount of extra, and reducing the amount of time and energy spent on other areas where the collection is not that much required. So these are our hardware components. Not much. We have just a regular laptop, and we can operate these in Windows, Linux, and Mac OS. And we use front-end React.js. We use FastAPI for backend framework, and we use SQL for database, and of course ARIMA for time series forecasting. So module 1, user and data management model. This model acts as the foundation of the system, manages user authentication, role-based access, image uploads, and storage of waste-related data. It ensures secure handling of user information and maintains historical waste records for further analysis. What what we are trying to do is, not all can access the admin panel. If all could handle the admin panel, there may be a person who can alter the information and can disrupt this entire waste collecting process. So we do not want that to happen. So we have introduced role-based access. If you're an operator, you just need to manage this truck and their representations. I- Whether the drivers are online, the drivers are working properly, or the drivers are reacting quickly for the alarm generator near them, etc. That role should be allocated to just single person. No others can access that role. So like that, visualizations can only be handled by the data analyst part, the data analyst persons. Not all can handle that thing, and no one ever knows that. Yeah, the core function, user registration and login, waste image upload and validation, image storage. We can store it in local or in cloud. Metadata storage in database, and we retrieve the data from the cloud for analytics part. And module 2, AI-based waste classification module. In this module, the core intelligent component of the system, it uses a CNN automatically to classify uploaded waste images into predefined categories. It reduces manual segregation, which is so hazardous for humans. In India, the waste segregation part is almost handled by the people, the cleaners, and it is most hazardous. People even throw human waste into the roads, and people handling them get more diseases, and nearly 80 people die from from the disease they get from the human feces. So that's the problem. It reduces manual segregation. We almost remove that entire problem, and it improves accuracy. So you just handle the bin and you use it to dump it into a vehicle that's collecting the waste. Core functions: image processing. We resize and normalize the image. CNN model execution, feature extraction. A image has certain features like we handle the pixels and RGB color extraction to get a clear image, even though the model may be 97% accurate. But if the image is not clear, there may be a failure of prediction. So we need to make this feature to a perfect scale, so that the image is clear and can be predicted perfectly. So that's what feature extraction is trying to convey here. Next is best category prediction, confidence score generation, and store classification result, etc., and model performance evaluation. Module 3, predictive analytics and smart scheduling. This model analyzes historical waste data to forecast future waste generation trends and transforms the system from reactive waste collection to proactive planning using time series forecasting. Historical data analysis. Like I said, we need to predict at what times the peak hours of waste collection happens, and waste trend identification, and ARIMA based time series forecasting. With this, we can predict how much amount of waste can be generated at a time. Okay, so, and we can predict future waste volume, like I said before. Identify peak waste periods, generate collection demand forecast, and we can optimize pickup frequency. If a particular area doesn't give much alarm on filling times, we can allocate that resource, that trucks, that drivers. We can allocate them to a different area where there's more number of collection, more number of emergency calling for picking up the bins, clearing the bins. We can allocate them to that area. Intelligent scheduling recommendation. So like we can predict and we can recommend the drivers. So there may be a peak time that's going to occur in this particular area. We can be so sure, and we can allocate resource to that particular area. And module 4. This module provides visualization, reporting, and administrative insights. It helps decision makers monitor system performance and optimize waste management operations through data driven dashboards. Okay, so core functions are admin dashboard interface and area waste reports. Yeah, these reports are so required for us to classify and analyze what may happen or what could happen in that area, so that we can allocate the resources, as I said. Waste category distribution charts, forecast visualization graphs, performance metrics, complaint feedback, and generate analytical reports for further classification and analytic parts. And this is our implementation. So as we look at here in the dashboard, we can see the analytics part and reports part. And in this feature highlights which area specifically requires action to be taken, and it will be highlighted here so that it can immediately be taken action. So this feature, fleet dispatch, we can spot the bins in the map, and we can spot the nearest drivers, and we can allocate those trucks to those nearest bins. We can use Digixtra for finding the nearest path for collecting those bins. And these are the classification results. Like just say it's capturing a live images. Every time a waste comes and falls into the bin, it can capture those images and it can classify it as glass, trash, and paper and cardboard, etc. Here we can look at the confidence level. It says 49.5%, 87.0%, etc. And yeah, that's it for our project. This is our whole implementation part, and we are implementing in a large scale. And these are our reference part. We have referenced these papers which are already in the internet, and the thing we are doing apart from them is we are implementing it to a certain industrial level, and we have included future waste prediction the time series forecasting. At what time, at what area, at what intervals the bin gets filled, and at what times we need to allocate these resources to at what time, like what period of time and what interval of time. We classify everything, we analyze everything, and we allocate the resources so efficiently that there won't be any stagnation of waste, and there won't be any pollution or air pollution. We just dispatch those fleet to collect those waste just as the bin fills.